हाँ सर स्टार्ट कर सकते
Yes, you can start.
हैं। Hello students. So my name is Swayam. I'm currently pursuing my MBBS at AIIMS Bhubaneswar. So it's the first class of a very fundamental chapter of our 11th class chemistry. That is structure of atom. Okay. Basically, this is also present in physics also. So you can clear your concepts here and practice question from physics also. Because the physics questions are a bit difficult one. Okay, so if you practice physics questions, so you'll get to know the chemistry one also. So try to solve physics questions also from this chapter. Okay, so let's start. uh, Before starting, uh, just revise the formula, few formula. I'm writing few formula 3 to 4 because it will be used in this session. Okay, so you have to know the formula. So the formula, uh, one is first one is Rydberg constant. The formula is using Rydberg constant, that is, if we'll take 1 by lambda, it will be RH. This is the Rydberg constant, and 1 by n1 square minus 1 by n2 square. N1 and n2 here are the principal quantum numbers. Okay, and this is z square. Okay. So this one is one formula. Then another formula is, if a electron jumps from a higher state to lower state, then how many numbers of that rays, in the hydrogen spectrum, how many electromagnetic rays will be produced? That the formula for that is n equal to, sorry, n into n minus 1 divided by 2. These are the basic formulas. Then another one is uh, the Bohr atomic model, radius and energy ones. If we write for the energy, it will be minus 13.6 square by. Okay. Then one is de Broglie's wavelength. Okay, the de Broglie's wavelength equation is very important, and you will use for 3 to 4 question here. Lambda is equal to h by mv. Here h equal to Planck's constant, m is equal to mass of the particle, and v is the velocity. Or you can write like this way: h by p. P here is the momentum, and you can convert this to kinetic energy also. In kinetic energy form, it will be h divided by 2m into kinetic energy. Okay, so we'll use these formulas in this today's session. So let's start with the first question. Okay, so first question is saying that calculate energy in joule corresponding to light of wavelength 45 nanometer. So what it is asking that, okay, the energy of the wave. So the formula for energy of the wave, we can write E equal to hc by lambda or h nu. Here lambda is the wavelength of the wave and nu is the frequency. Here it is given that wavelength is given, so we can use the formula hc by lambda. So E is equal to hc by lambda. The value of h given here, value of h given 6.63 into 10 to minus 34 joule second, into c is equal to, c is the speed of light. What is the speed of light? 3 into 10 to the power 8 meter per second. So we'll put here 3 into 10 to the power 8 meter per second divided by, what is the lambda given, means what is the wavelength given. So let's put the wavelength 45 nanometer. 45 nanometer means 45 into 10 to minus 9 meter. Okay. So after you solve this equation, you will get the answer 4.42 into 10 to the minus 18 joule. So the option D is correct. Okay. So we'll the for the energy of wave, remember these two formulas, these two basic formula you will encounter in every chapters of electromagnetism. Okay. So so let's move on to second question. Just a minute. Okay. So second question is asking which of the following is never true for cathode rays. So first of all, we have to know that what is cathode rays. If you draw a vacuum chamber and connect it here to a high voltage supply, and here are the two electrodes, anode and cathode. Okay. So when you connect the electrodes to a high voltage source, then the air within this will ionize. Okay. So it will be ionized. The atoms here, these are the atoms. Okay. These atoms will be ionized. Then the when the atoms will be ionized, the electrons will pop out. Okay. Then electrons will travel to the positive electrode, and the atom, the remaining atom is, if you a neutral atom here is a neutral atom. If you remove a electron from this, then it will become a positive atom. Okay. Then the electron is negatively charged, so it will move towards the positive electrode, and these atoms here, the atoms are positively charged, so it will move towards the negatively charged plates. Okay. So these streams of electrons and these streams of the ions are named anode rays and cathode rays. So the electrons streams are called as cathode rays, and the positively charged ion streams are called as anodes. Okay. So we have to study about their properties. So let's move one by one. Okay. The first option says they possess kinetic energy. Okay. So it is saying that the cathode rays means electrons. Electrons possesses kinetic energy. Obviously, it is correct. What is the logic behind this? Because electrons carry mass, plus when moving, these electrons also have some velocity, some speed. So if a electron possesses mass and has some speed also, so it has kinetic energy, right? So the first option is correct. Let's move to the second option. They are electromagnetic waves. You are not confirmed that it is electromagnetic waves or not. So let's move on to third option. Then we'll encounter the B option at last. Okay. They produce heat. Okay. The electrons possesses some momentum. Okay. When they will hit this electrode, okay, they will produce some heat through collision. You know, like none of the collisions are elastic. Okay. So if a collision is not elastic, then some of the energy will be uh, distributed to the surface by a heat, like in the form of heat. So heat will be generated when electrons will bombard to the electrode. Okay, so option C is also correct. Let's move to the option D. They produce mechanical pressure. When does a particle imparts pressure at any surface? If let's assume it is a mass of m and it is a wall. So when it bombard the wall, it exerts some force on it. If it exerts a force on the wall, so there will be pressure. Okay, pressure is nothing but force by area. If it is imparting force, if it is exerting force on the wall, so obviously there will be pressure. Okay, and it is a mechanical pressure because it is in contact with the wall. Okay, so the options A, C, and D are correct. So what will be the wrong option? Option B, because they are electromagnetic waves. No, cathode rays are not electromagnetic waves because they are uh, consisting of their like electrons. Electrons are not electromagnetic waves. Okay, so let's move on to question number 3. Which of the following series of transitions in the spectrum of hydrogen atom falls in visible region? Okay, so it is asking that if do you know if a electron, suppose these are the energy levels or orbit, it is higher energy level orbit and it is lower energy level orbit. Okay, so if a electron comes from higher to lower energy level, it radiates some energy. Okay, it radiates some energy, and this energy is converted in the form of a wave. Okay, so from each for hydrogen atom, there are constant spectra. Just like these are the names: Lyman, Balmer, and Paskin, and Brackett. Okay, so let's find out what are these. Suppose this is the nucleus of a hydrogen atom. This is the uh, radius number one, like orbit number one, orbit number two, orbit number three, and four. Okay. If an electron jumps from jumps from second orbit to the first orbit, this is called as Lyman series. And this falls in ultraviolet region. If an electron jumps from second orbit to the ground or first orbit, it will be called as Balmer series. Okay. Similarly, from third to ground, it will be called as Pascal. And here is the fourth. If it jumps from fourth, it will be called as bracket. The Balmer series falls in visible spectrum. Means if a electron jumps from second orbit to ground orbit, we can clearly see the wave formed by that electron because it falls under the visible wavelength. But Pascal and bracket we can't see because uh, these series falls under like infrared. Okay, infrared region of wavelength. Okay, so Lyman, UV, Balmer, visible, Pascal and bracket, infrared. Okay, let's move on to fourth question. Okay. Which of the following series of the transition in the spectrum of hydrogen atom falls in visible range? So, what will be the correct answer? Balmer will be the correct answer because in the Balmer series, the waves are in visible range. Okay. Question number 4. Based on equation E is equal to minus 2.178 into 10 to the minus 18 z square divided by n square joule, certain conclusions are written. Which of them is not correct? So let's go one by one. The option A says larger the value of n, the larger is the orbit radius. N, what is n? N is equal to principal quantum. Okay. Uh, you know that the principal quantum like radius is directly proportional to principal quantum number. Higher the principal quantum number, higher will be the radius. Okay, so the first option is larger the value of n, the larger is the orbit radius. Okay, so first option is correct. Then move on to option number B. Equation B says equation can be used to calculate the change in energy when the electron changes orbit. Yes, we can cause this formula E equal to minus 2.178 into 10 to the minus 18. This gives us the formula for energy level of orbit. So uh, we'll if we put 1 at if we if we'll put n equal to 1, we'll get energy level of orbit 1. If we'll put n equal to 2, we'll get energy level of orbit 2. Okay. So subtract these, if we subtract these two, we'll get the difference, the energy change of the electron when it jumps from one orbit to one another. Okay. Then option number C. For n equal to 1, the electron has a more negative energy than it does for n equal to 6, which means that the electron is more loosely bound in the smallest allowed orbit. Let's find out E equal to minus 2.178 and minus 18. In n equal to 1, so minus 2 point, let's suppose 178 into z square. If n equal to 1, it will be z square. Then E6 minus 2.178 into minus 18 z square divided by 6 square, 36. If you divide this negative number by 36, it will be some lesser than minus 2.178, means the lesser negative value. Okay, suppose it is around 1.05. Okay, so what does that mean? If it is a more negative energy means attractive force is more the attractive force, more will be the negative energy. Okay. uh, what is the statement? Which means that the electron is more loosely bound in the smallest allowed orbit. Obviously, is the smallest allowed orbit means E1 has a higher negative number, higher negative energy. That means it is bound closely to the nucleus. Okay, it has more attractive force towards the nucleus. Okay, so option C is the C is also correct. No, option C is incorrect. Why? Because it is written more loosely bound in the smallest allowed orbit. No, it is the opposite. It is more closely bound in the smallest allowed orbit. We found out that the negative energy is more in the smaller orbit. Okay. Let's read out the D option also. The negative sign in equation simply means that the energy or electron bound to the nucleus is lower than it would be if the electrons were at the infinite distance from the nucleus. Yes, it is correct. Why? If it is a nucleus, here it is a nucleus. Suppose this distance is infinite distance. If here, if you place an electron here, the energy of electron will be zero. Okay. The more you move the electron closer to the nucleus, it will get more and more negative. Suppose here the electron has minus, uh, not in minus, okay, minus 0.5, 0.5 joule energy. Here it will be minus 0.8 joule. Here it will be minus 1.28 joule. Okay, the more you move closer, the more you get negative value of energy. Okay, so the option C is not correct. Question number 5. The Bohr orbit radius for the hydrogen atom is approximately 0.530 angstrom. The radius for the first excited state of the orbit is. So it is a simple formula based question. It is given that the orbit corresponding to n equal to 1 has a radius of 0.530 angstrom. Okay. Uh, it is asking us to calculate the radius of the orbit n equal to 2. So what is the formula for radius? Rn is equal to R1 into n square. Okay. Here Rn is equal to the desired radius, and R1 is the radius of the first orbit, and n is equal to principal quantum number or the number of orbit. So here Rn means R2 for second orbit, it is R2, then R1 given 0.530 angstrom. And here n is equal to 2. So let's put that here. 2 into 2 square. 0.530 angstrom into 4. It will be 2.12 angstrom. Okay. So the answer is option D. Yeah. Uh, Question number 6. The radius of hydrogen atom in the ground state is 0.53 angstrom. The radius of lithium 2 plus ion in a similar state is. So what? Notice the difference between the previous question and this question. In the previous question, it was asking that uh, the radius of the second orbit of the same hydrogen atom. Here it is asking the radius of lithium 2 plus ion. So how are they similar? Okay, how can you derive the radius of the lithium 2 plus ion from hydrogen atom's radius? There is a formula. Okay, what is the formula? R is equal to R1 divided by Z. Okay, it is for the first orbit. First orbit of any ion other than hydrogen having only one electron. Okay, so let's find out the lithium one. So R is equal to R1 of hydrogen, that is 0.53 angstrom, divided by what is the Z value of lithium? Z means atomic number. Atomic number given is 3. So atomic number is equal to 3. So it will be, the answer will be 0.17 angstrom. Here, notice that the more you increase the Z, means a hydrogen, helium plus ion, and lithium 2 plus ion. Each of these atoms have only one electron. Okay, so this formula will be uh, can be applied to these atoms. Okay, so the Z value for hydrogen is 1, helium is 2, lithium is 3. So the radius of hydrogen atom will be the largest. Okay, because Z is in the here. Okay, here we can see if R1 is given, R1 divided by 1 will be greater than R1 divided by 2 will be greater than R1 divided by. So the radius of hydrogen atom for the same principal quantum number will be higher than that of helium plus ion and lithium 2 plus ion. Okay, so let's move on to question number 7. According to law of photochemical equivalence, the energy absorbed in ergs per mole is given as. Okay, what is ergs? Ergs mean this is the unit of energy, unit of energy in CGS system. Okay, you might have read CGS system and the system in the fundamentals of physics in the first chapter of physics. Okay, so I'm not going to that, but it is the ergs is the unit of energy in CGS system. Okay, when we convert joule to ergs, we'll find out that 1 joule is equal to 10 to the power 7 ergs. Okay, so let put that value here in the energy formula. What is the energy formula? Energy is equal to Hc Na. Energy equivalence formula is equal to Hc Na divided by lambda. Okay, here H value is 6.62 into 10 to power minus 34 joule. Okay, we have to convert it to ergs. So let's multiply 10 to the power 7 ergs. Then 3 into light speed, it is the speed of light. C is equal to speed of light. 10 to the power 8. Okay, it is meter per second, but we have to convert it into the CGS system, means centimeter. So we have to multiply 10 to power 2 and the Avogadro's number 6.02 into 10 to the power 23 divided by lambda. When you solve this equation, you'll get the value of 1.196 into 10 to the power 8 divided by lambda. Okay, so the correct answer is option number B. Okay, law of photochemical equivalence is the fundamental principle relating to chemical reactions induced by light, which states that for every mole of a substance that reacts 6.022 into 10 to the 23 quanta of light are absorbed. The photochemical equivalence law is also sometimes called as Stark-Einstein law. Okay, you have to remember this principle or law. Okay, so like you will be confused in future. What is photochemical equivalence? Okay, just go through this formula. Okay, and remember this and write down it somewhere in the short note of atomic structure chapter. Okay, it's question number 8. If ionization potential for hydrogen atom is 13.6 electron volt, then ionization potential for helium plus ion will be. Okay, so ionization potential. what it is. Ionization potential means if it is an hydrogen atom, it is a nucleus, and in the first orbit there is an electron. In the first orbit, what is the energy of electron? Minus 13.6. Ionization means we have to remove the electron from the atomic structure, means the from the attractive force of nucleus. Okay, we'll place it to the infinity, position infinity. In position infinity, the energy of electron will be zero. We had discussed earlier also. In infinity, energy of electron will be zero. So the energy required to place this electron from the orbit to the infinity is called as the ionization potential. How much energy will be required? 0 minus minus 13.6 electron volt. Okay, that means 13.6 electron volt. Okay, this is the correct way of calculating ionization potential. We have to subtract the value from 0. What is value? The subtract the energy of the electron. Okay, so let's calculate the energy of electron in helium plus ion. It is a helium plus ion, and it has also a single electron. If it is single electron, let's calculate the energy for it. Because it is not in hydrogen atom, we have to calculate it for the helium 2 plus helium plus ion by putting the Z value 2. Okay, so formula is E equal to minus 13.6 into Z square divided by N square. Minus 13.6. What is the Z value of helium plus? Means atomic number. It is 2, means 4. What is the N? N means the orbit number. It is in the first orbit. So 1. So minus 13.6 into 4. That will be 54.4 electron. Okay. It is the energy of the electron in first orbit of helium plus ion. So what will be the ionization potential? Okay. Ionization potential will be energy at infinity minus energy at 1. What is the energy of at infinity? 0. Minus energy at orbit 1 is equal to minus 54.4 electron volt. 0 plus 54.4 electron volt. That will be 54.4 electron. Okay. So the answer will be 54.4 electron volt. We require this much energy to remove the electron from helium plus ion. Okay. So let's move on to next question. If r is the radius of the first orbit, the radius of the nth orbit of hydrogen atom is given by. Let's first orbit radius is given r. We have to find the radius for nth orbit. What is the formula? Formula will be r n square. Okay. Remember this formula for the radius of nth orbit. Okay, because it is very fundamental formula. Like in atomic structure, after you finish this chapter, you will get to know very like few formulas. Like for energy, one or two formula. For radius, one or two formula. Then you will find it for the de Broglie's wavelength also. Then you will find it for potential energy, kinetic energy. Okay, so write it down. in your short note at one place and revise again and again to remember the formulas. Okay. Or else you will forget the formulas at exams. Okay. The radius of nth orbit is equal to R1 n square. The energy of an electron in the nth Bohr orbit of hydrogen atom. It is also just a direct formula. What is the formula? Minus A energy at nth orbit equal to E naught. E naught into Z square divided by n square. Okay. If it is for hydrogen atom, then E naught into Z for hydrogen is 1. So 1 divided by n square. E naught divided by n square. E naught means the energy of first orbit. So, or else you write U1. Okay. U1 is equal to, minus 13.6 electron volt. But it is not sufficient for you. You have to remember at least up to fourth orbit, all the energy levels. Okay. So let's find out. E2, energy level of orbit 2, minus 13.6 electron volt divided by n square means 2 square minus 13.6 electron volt divided by 4. It will be around minus 3.4 electron volt. Similarly, for E3, you have to calculate. How will you calculate? Minus 13.6 electron volt divided by square of 3. That will be 13.6 divided by 9. To calculate, it is around minus 1.5. It is around that. Okay. And E4 will be minus 13.6 divided by 4 square minus 13.6 electron volt divided by 16 is equal to minus 0.85 electron volt. So you have to remember the energy levels of first 4 orbits. That is, here we can write, summarize. Here it is a nucleus, first orbit, second orbit, third orbit, and fourth orbit. First orbit energy is 13.6. Here it is 3.4 minus 3.4. Here it is 1.5. Here it is 0.85. Okay, you have to remember this because sometimes it asks what is the energy released by the electron if it jumps from n equal to 3 to n equal to 1. That means you have to just subtract minus 1.5 minus 13.6. That will be 13.6 minus 1. Okay. If you remember this value, you don't you you will find it easy to calculate. Okay. So let's move on to next question. The spectrum of helium is expected to be similar to that. Options are hydrogen, lithium plus ion, sodium, and helium plus ion. Okay. So, spectrum. What is spectrum? We talked about spectrum, Lyman series, Balmer series, Baskin series, and Brackett series. Okay, these are the spectrum of electron. Okay, the spectrum is depends on the number of electrons, not on the numbers of protons or neutrons. If helium has two electrons, the spectrum of helium will be similar to that atom that possesses two electrons. So out of these atoms or ions, which of these contain two electrons in their outer orbit? Hydrogen contain one electron. Lithium plus contain two electrons. Sodium, it contains 11 electrons. Okay. Helium, helium plus contains one electron. Okay. Helium and lithium plus ions are similar in the number of electrons. Helium has also two electrons, lithium 2 plus has also two electrons. So the spectrum of helium will be similar to that of lithium plus ion. Okay, let's move on to next question. In hydrogen atom, the de Broglie wavelength of an electron in the second Bohr orbit is given. That is A naught. Okay, A naught is given. It is asking that what will be the de Broglie wavelength of that electron in second Bohr orbit. Okay, so let's find out. Lambda is equal to, we know, 2 pi Rn. It is the formula for de Broglie wavelength in the Bohr orbit. If it is asking for the second orbit, we have to find out the Rn, means R2. Lambda is equal to 2 pi Rn. It is the formula for de Broglie wavelength of an electron in Bohr's orbit. So let's find out this R2. R2 will be here. Previously, I told the formula for radius. Let's put that here. R2 equal to R1 into n square. Okay, R1 into n square. R1 is given 52.9 picometer. N is 2. N is equal to 2 equal to 4. So R2 will be 211.6 picometer. Okay. So the de Broglie wavelength for the second orbit electron will be 2116 picometer. There's a radius. Let's find out the lambda. The de Broglie radius is 211.6 picometer. Lambda is 2 pi r 2 2 pi into 211.6 picometer. That will be around 211.6 pi picometer. Okay. So the answer will be C, that is 211.6 pi picometer. Here it is also given the 211.6 picometer, but the answer will be 211.6 pi meter after, sorry, picometer, after putting it in the formula of lambda equal to 2 pi r. Okay. Do you know how this formula is derived? Okay. Let's, okay. For if it is the first orbit. Okay, if it is a first orbit, then there will be a one wave only. Okay, there will form one wave, and the wave, lambda of this wave will be same as that of the uh, same as that of the 2 pi and the circumference of this first orbit. What will be the circumference of the first orbit? 2 pi r n. 2 pi r. So this is the formula. Okay. So next question number 13. Which one is the wrong statement? Okay, let's find out. Uh, option A. The uncertainty principle is del E into del T is greater than or equal to h by 4 pi. Okay. If you know the formula of Heisenberg's uncertainty principle, you should know this form also. It is also a form of Heisenberg's uncertainty principle. Okay. So remember this. So the option A is correct. Option B. Half-filled and full-filled orbitals have greater stability due to greater exchange energy, greater symmetry, and more balanced arrangement. You know this. during the filling of electrons, you were taught that half-filled and full-filled orbitals have high, like greater exchange energy. That's why they lose more and more energy and possess minimum energy. And minimum energy signifies the stability of that orbital. Oh, this is the relation, no? The energy stability is stability of an orbital is indirectly proportional to energy. The less the energy, the more stable will be the orbit or orbital. Okay, if half-filled and full-filled orbitals have greater exchange energy, means they lose more energy by exchanging their electrons with each other. If you go through NCERT on the last page of this chapter, you will be seeing a green box. There, the concept of the exchange energy is explained. If it is a half-filled orbital, okay, then this first electron can exchange with this electron, this electron, and this electron. The second electrons can exchange with this third electron, fourth electron, and fifth electron. So a third will exchange with this and with this. Fourth will exchange with this only. Okay. So the number of exchanges are more here. Okay. So you have to remember this: the greater the exchange energy, the stable the orbital. Option number C, the energy of 2s orbital is less than the energy of 2p orbital in case of hydrogen-like atoms. You'll be confused in these options only. Okay. So what is the energy formula of a orbital? N plus L. If you like, if there are orbitals like 2p, 3d, 4s, how will you find out that which of these orbital have uh, like lesser energy or greater energy? We'll put this formula n plus L. Put this formula here: n equal to 2 plus p. What is the L value of p? N plus L. It is 1. It is 3. 3d, 3 plus 2, 5. 4s, 4 plus 0, that is 4. So the energy of 3d is highest, then 4s, then 2. Okay, this is the sequence of energy levels. Okay, if it is the sequence of energy level, then the statement C should be correct, because 2s and 2p, between 2s and 2p, 2s is equal to n plus L, means 2 plus 0, here 2 plus 1. So 2p possesses greater n plus L value, that should have like higher energy, but this is not the case. Why? Because in hydrogen like atom means the atoms which possesses only one electron have degenerate orbitals. Degenerate orbitals means the all the orbitals in the same quantum number, in the same with the same quantum number, have same energy. Means 2s orbital, 2p orbital have same energy. 3s, 3p, 3d orbitals have same energy. Okay, only in hydrogen and hydrogen like atoms or single electron system. Let's move on to question number 14. A 0.66 kilogram ball is moving with a speed of 100 meter per second. The associated wavelength will be. How will you calculate a wavelength of a ball? You will put the de Broglie's wavelength formula. What is the de Broglie's wavelength formula? Lambda is equal to Planck's constant h divided by mv. Here h is Planck's constant, m is mass, v is velocity of the ball or any particle. So lambda will be put the value of h 6.6 into 10 to a minus 34 joule second. What will be the mass? 0.66 kilogram. What is the velocity? 100 meter per second. If we'll calculate this 6.6 into here multiplies this 10 by minus 34 divided by 66 and 10 to minus 35 will be the answer. 1 into 10 to the power minus 35 meter is the wavelength of the ball which is moving with a speed of 100 meter per second. Okay. Okay. This is the correct answer. Question number 15. The measurement of the electron position if it is associated with an uncertainty in momentum which is equal to 1 into 10 to the power minus 18 gram centimeter per second. The uncertainty in electron velocity is. So it is given that the uncertainty in momentum is 1 into 10 to the power minus 18 gram centimeter per second. Uncertainty in electron velocity is it is asking the uncertainty in electron velocity. The mass of electron is given 9 into 10 to, 10 to the power 28 gram. Okay, so let's calculate the uncertainty in del V. How will you calculate? Which formula will be used here? Correct. Heisenberg's uncertainty principle. Let's write the formula. Del x. What is the original formula? Del x means uncertainty in position into uncertainty in momentum is greater than equal to h by 4 pi. Okay. So, but we have to convert it into del v means del x del sorry del v. Let's put here del p means momentum converted into mv formula m del v greater than h pi. What it is asking uncertainty in electron velocity, that means we have to find out this. So del v del just a minute, I have written wrong. Okay. Uh, so let's put the formula here. Del x del p greater than h by 4 pi. Okay. Del v will be del p by m. If del v is del p given, m given, what is the del p? 10 to power minus 18. What is mass? 9 into 10 to minus 28. So if we calculate this, then we'll get 1 like nearly 1.1 into 10 to the minus sorry plus 9 centimeter per second. So the uncertainty in velocity of that electron, which is an uncertainty in momentum of 1 into 10 to the minus 18, will be 1.1 into 10 to the power 9 centimeter per second. But in these four options, there is like no 1.1 into 10 to the 9. So we'll go to the nearest one. So they will convert into 1 into 10 to the 9 centimeter per second. Okay. So option A will be the correct answer. Question number 60. If uncertainty in position and momentum are equal, then uncertainty in velocity is. Let's put the formula here. What is given? If uncertainty in position del x is equal to del p. So what will be the uncertainty velocity? Del v is equal to 4 pi m by h. Got it? So The uncertainty will be, it is the basic formula del P into del X is greater than H by 4 pi. Okay. Or you can write it like M into del V into del X is equal to H by 4 pi. Here given del P and del X are equal. So del P, this one del P, and it is also del P because it is same with the del X. So H by 4 pi. Or H by 4 pi is also equal to M del V. So you can write it like M del V equal to H by 4 pi del V, or else del V square is equal to H by 4 pi M square del V equal to root over of H by 4 pi M square. If you 1 by 2, here root over of 4 2, root over of M square will be M, and H by 4 H by pi. Okay, so the correct answer will be option A. The last question of this session. The mass of an electron is 9.11 into 10 to the minus 31 kg. Planck constant is 6.62. The uncertainty involved in the measurement of velocity within a distance of 0.1 angstrom is. So, what are the given components? Del x, uh, del x is given 0.1 angstrom, that is 1 into 10 to the minus 11 meter. Del P, we all know, H by 4 pi del X. Okay. M del V equal to H by 4 pi del X. We have to find out the del V. Del V means H by 4 pi del V into del X. Sorry, 4 pi M del V into M del X. Let's put the value here, 6.6 into 10 to the minus 34, 4 pi into, what is the mass given of electron? 9.11 into 10 to the minus 31 into del X. What is the del X? 0.1 angstrom, or 10 to the minus 11 angstrom. Okay. So the answer will be 5.79 into 10 to the power 6 meter per second. Okay. Option number D. Okay, the correct answer is option D. So let's end the session here. We'll continue with the other 18 question in the next session tomorrow. Till then, revise the formula of this chapter so that you can uh, answer all the questions by yourselves only. Okay, I'll just tell you the approach and the calculation part, but you have to remember the formulas. Okay, thank you.